start with the next chapter, that is current electricity. Let's start from very basic. First is electric current. So electric current is defined as the rate of flow of charge. That is equals to, we take, Alan, am I audible to you?
Yes, sir.
5 minutes more. Eva, Parag, Alan. Five more minutes. Let's start. We'll start with the third chapter, that is current electricity. So basic current, it is defined as the rate of flow of charge through any cross-sectional area of the conductor. So I equals to Q over T. Let's wait 5 minutes. So current is defined as the rate of flow of charge through any cross-sectional area of the conductor. Steady current equals to Q over T. Q is the charge, T is the time, and Q also by the property of the electric charge is quantization of charge. Q equals to Ne over T, where N is number of electrons and E is the charge on electron or electronic charge. Next, current is not always steady. There are two types of current. Average current. Average current is defined as delta Q over delta T. That is Q2 minus Q1 over T2 minus T1. And instantaneous current is, basically we have to take the limiting value of average current, that is dQ over dt. Is instantaneous current. Current is a scalar quantity. Its SI unit is ampere. How will you define 1 ampere of current? So I equals to Q over T. When 1 coulomb of charge flows for 1 second through a cross-sectional area, then the current is said to be 1 ampere. Okay. When 1 coulomb of charge flows for 1 second through a cross-sectional area, then the current is said to be 1 coulomb. Now, direction of current. Conventional current, the direction of the flow of positive charges is taken as the direction of the current. So these are the positive charges and this is the direction of the current. So conventional current, we take the conventional direction of the current, that what we believe the direction of the current is taken as the direction of the positive charges. Electronic current, the direction of the flow of electrons gives the direction of electronic current. Electronic current always flows in the opposite direction of the conventional current. These are negative charges, flows towards left, and I flows towards right. Just remember, charge entering per second at one end of the conductor is always equals to charge leaving per second at the other end. That is, let it be this conductor. I is the current flowing, entering through this end and leaves from this end. So I equals to I. This is very important. I equals to dq over dt. So dq equals to I dt. If you integrate, you'll get charge. If we have a graph, IT graph, I versus T graph, then area under the curve will give you the charge. Try this question. Time is given 1 minute. Current is 400 milliamperes. Charge is 1.6 10 to the power minus 19 coulomb. Now we have to calculate the number of electrons passed through the bulb. Fine. Everything is given, and write your answer in chat box fast. Fast. We have to calculate I. So I equals to Q over T and Q equals to NE over T. Now fast. Let me know the answer. And write your answer in chat box. And we have to calculate. So I times E, I times T over E. Done. Parat, Allen, Saifullah. Done. Fifteen into 10 to the 19. Rest of you write your answer in chat box fast. What is I? 400 milliampere. Fine. What is time? First, then we have to change milliamperes into ampere. Saifullah. Parat, Allen, write your answer in chat box fast. Fifteen into 10 is sure minus 20. Just a minute. So I equals to 400 into 10 to the power minus 3. What is I? 1 minute means 60 seconds over 1.6 into 10 to the power minus 19. तो जाना ही नहीं कहीं। So what is I? 24,000 10 to the minus 3 over 1.6 10 to the minus 19. 24 into 10 to the power 24 over 1.6 into 10 to the 19 divided. If you divide 16, 240 divided by 16, how much? Can anybody let me know, please? 240 divided by 16 is 15 into 10 to the 19. That is 1.5 into 10 to the 19 ampere. Sorry, number of electrons. Sorry, number of electrons. Okay. Parat 15 into 10 to the minus 20.
No, sir, I accidentally wrote the minus.
1.5 into 10 to the 20. 1.5 into 10 to the minus 10 to the 20 is the answer. Alan is correct. Sorry, Saifullah is correct. Alan, what about your answer?
Yes, sir.
You didn't write in chat box. Next is Ohm's law. Hold a minute. Aksha, why are you late? And Maimuna again. Aksha, why are you late? Aksha, why are you late? Now, Ohm's law. Ohm's law. Alan, what does it state? Ohm's law. It states that the current is directly proportional to the potential difference applied across a conductor, provided the physical conditions remains constant. Physical condition means temperature and pressure remains constant. So V is directly proportional to I. And if you remove this proportionality constant, then you have to keep you have to use a constant, that is R. So V is directly proportional to I. If you remove this proportionality constant, then R will come V equals to I, where R is the resistance of the conductor. Now graph between V and I. So tan theta, this is the graph directly proportional, and tan theta equals to V over I. Our slope, this is slope. Slope will give you the, in VI graph, slope gives you the resistance. So V and I, there are two temperatures, T1 and T2. If the question comes and asks which is bigger, T1 or T2, so tan theta 1 is greater than tan theta 2. So resistance R1 is greater than R2, so T1 is greater than T2. If the resistance is high, then the temperature will also be high. Now resistance, the property of the substance by the virtue of which it opposes the flow of current. The property of that property of the conductor is known as resistance. So R equals to V over I. Factors on which the resistance depends. First is resistance directly proportional to the length, and second, resistance inversely proportional to the area of cross section. It means if we increase the length, then the resistance will increase, and if we increase the area, the resistance will decrease. Resistance also directly proportional to the temperature. If we increase the temperature, the resistance also increases in case of conductor. Combining first and second, so R is directly proportional to L over A. If you remove this proportionality constant, then resistivity will come. The R equals to rho L over A. Now, what is resistivity? The SI unit of resistance is ohm. What is resistivity? Resistivity is also the resistance. So, R equals to rho L over A. If L equals to 1 meter and area equals to 1 meter square, then resistance equals to resistivity. It means if we take a wire of length 1 meter and area of cross section 1 meter square, then the resistance at that time is said to be the resistivity of the conductor. Now its SI unit is ohm meter. Now resistivity. Resistivity basically intrinsic property of the substance. If we take a wire having unit length and unit area of cross section, then the resistance of the conductor is said to be the resistivity. Resistivity, it is independent of the shape and the size of the conductor. It completely depends on the material of the object and the physical conditions as well. SI unit of resistance is ohm. It is denoted by this symbol. How will you define 1 ohm? So R equals to V over I. If we take a potential difference of 1 volt, let it be a 1 ampere of current flowing through a conductor. On applying a potential difference of 1 volt, then the resistance is said to be 1 ohm. Now try this question. 4 minutes. Try this question. Write your answer in the chat box. Fast. The question is very simple. C is the answer. And what about others? Alan, write your answer in chat box, please, fast. Farhat, write your answer. Mahmuna, write your answer. Everyone, write your answer, please, fast. Fast, write your answer. Mamuna, write your answer. Am I audible to you? Aksha, write your answer. What happened to you? Why are you not responding? Saifullah, have you written the answer?
Yes, sir.
C. Farhat A. Alan. Mamuna, write your answer. Eva, write your answer. Please write your answer. Okay, what is the formula for the what is average current, Alan? Could you let me know the formula for average current?
So delta I by T.
Delta Q by T. What is the formula, Farhad? What is the formula for resistance? Farhad,
Yes, sir.
what is the formula for resistance?
R rho L by A.
Okay. What is resistivity? Saifullah, what is the resistivity of the conductor?
RA by L.
Sorry,
Are you asking me the formula or definition, sir?
definition. Resistivity.
Um,
Intrinsic property. Fine. A wire having unit length, unit area of cross section, then the resistance is said to be, the resistivity is said to be, sorry, the property of the material is said to be the resistivity of the conductor. It is an intrinsic property. Okay. On which two factors resistance depend? Mamuna. Mamuna, am I audible to you? Mamuna, if I increase the length, resistance will increase or decrease? Now let's do this question. Okay. The resistance of the wire is R and it is melted and stretched to N times its original length. So R1 equals to R, L1 equals to L, and L2 equals to N times L. It's new resistance. We have to calculate new resistance. Look, since resistance equals to rho L over A. Now, volume remains constant. So area A1 L1 equals to L2. So volume basically area times length. Now let it be A1 is A. So L1 is L, A2 we have to calculate, and L will be cancelled out. So A2 is A over N. Now new resistance. New resistance. So R1 equals to rho. Resistivity will not change because resistivity depends on the material. So rho L over L1 over A1, that is rho L over A, and R2 equals to rho L2 over A2, rho, what is L2? N times L, N is A over N. Now, this is N square rho L over A. Now, R2 over R1 equals to what is R2 over R1? Or we can say, so R2 equals to N square rho L over A. And what is this? This is R1. N square R1 and R1 is R. Now, this is the answer. C is the answer. Okay. Alan, did you get it? Everyone? Farhad,
So
you made a mistake somewhere in calculation, not NR. This is the way to to approach this question? Okay, Farhat. Mamuna, am I audible to you? Heba,
Yes, sir.
Aksha, am I audible? Now, conductance. Conductance is defined as the reciprocal of resistance. Its SI unit is per ohm or Simon. Conductivity is reciprocal of resistivity. SI unit is per ohm per meter or mho per meter. Now, drift velocity. Alan, what is drift velocity?
So it's the number of free electrons.
What is Ohm's law, Saifullah? What is Ohm's law?
The amount of electrons are flowing
Ohm's
through.
law. Ohm's law. Ohm's law.
It says that I is directly proportional to potential difference V.
Now, average drift velocity. So the average velocity acquired by the electrons in presence of, let it be this a conductor. Okay, this is a conductor, and all we know that conductors have free electrons. Fine. So let it be a conductor. It must have free electrons. But in absence of electric field, they move randomly, like this. Fine. So the average velocity will come out equals to 0. But when we apply an external electric field, it means when you joined a battery across its end, so there is the distance between the two ends, let it be D. So E equals to V over D. So electric field will be applied across its end. So in presence, so the average velocity acquired by the electrons in presence of external electric field, that velocity is known as average velocity. Is it okay till here? I repeat, what happens in absence of electric field, the electrons, they also move randomly. So the average velocity comes out equals to 0. But what happens when we apply a potential difference across its ends? A electric field is applied. So the average velocity acquired by the electron in presence of electric field, that velocity is known as drift velocity. Okay.
Okay, sir.
So the average velocity acquired by the electrons, by the free electrons of the conductor in presence of external electric field, that is, this is known as average, this is known as drift velocity. So Vd equals to E. E is the charge on electron, capital E is the electric field, tau, this is known as tau, relaxation time, and m is the mass of the electron. So this is the formula for drift velocity. Now, what is relaxation time? The time interval between two successive collisions with the positive ions in metallic conductor, that is known as relaxation time. Just remember this formula. Fine. Now, relation between current and drift velocity, I equals to NEA Vd. Vd is the drift velocity, A is the area, A is the charge, and is the electron density. What do you mean by electron density? The number of electrons per unit volume. And is electron density. Just a minute. So N is electron density. Now current density, the amount of charge flowing per second per unit area perpendicular to the direction of the flow of charge is known as current density. So current density is current flowing per unit area. I over A is known as current density. Fine. It is a vector quantity. It is a, just remember, it is a vector quantity. It is a vector quantity having same direction as that of current. Okay. So it is a vector quantity having same direction as that of current. So in the second figure, this is A, this is B. Now the current is flowing in this way. This is an area vector making an angle theta with the current. So J equals to I over A cos theta. And if you move this side, so I equals to J cos theta. Whenever the cos theta comes in any physical quantity, then we have to take the dot product, J dot A. This also implies that a current is a scalar quantity. Now, this is current density. Okay, what is the formula for current density, Mamuna? What is the formula for current density?
Sir, can you show the formula again?
Okay. What is the formula for drift velocity, Alan? You have to remember the formula. Vd equals to E tau. Just write down in your notebook. What is the formula, Saifullah, for drift velocity? I am showing you again. Just write.
Vd equals to electron into electric field into relaxation time by mass.
Write down this formula in your notebook. All right, fast. E tau over m. Fine. This is the formula for. This is the formula for current density. The relation between I current and this I equals to NEA Vd. Note down each and every formula in your notebook. Okay. Current density is a vector quantity having same direction as that of current. Now, mobility. Mobility is defined as drift velocity per unit electric field. Okay, so mobility is defined as drift velocity per unit electric field, E tau over m. So E tau over m, where tau is the relaxation time, as is the mass, E is the charge in electron. SI unit is meter square per volt second. This question is very simple. Try. Write your answer in chat box. Everyone, Mehamuna, why are you not responding? Aksha, am I audible to you? Write your answer in chat box, folks. There is one more relation. Resistivity in just a minute. Resistivity in terms of relaxation time. That is rho equals to m n square tau. Just remember this relation also. Okay. Now try this question and write your answer in chat box. You have 2 minutes, 2 to 3 minutes to do this question fast. A is the correct answer. Mamuna is correct. Alan is wrong. Look, what is the drift velocity? E tau over m. So this is A. Fine. Electrical resistivity, this B. B is 4. Just a minute. Farhad A. B belongs to 4. Drift velocity. Current density is relaxation period. P is 1. Okay.
Answer C is 1.
Okay, just a minute. So A is 3 and B is obviously this.
Answer C is 1.
A 1. This is C. And this is B. And I equals to, this is current density. I equals to NE. So A is the answer. This formula based question. Now try this question. Easy. Again, 2 minutes just to think over this question. Very easy question. Just hardly 2 minutes. Across a metallic conductor of the non-uniform cross section, a constant potential difference is applied. The quantity which remains constant along the conductor is. Write your answer in chat box fast, everyone. Mamuna, Aksha, Saifullah, Eva, write your answer in chat box. Everyone. Fast, write your answer. Farhat. Write your answer. Please write your answer in chat box. Which physical quantity remain as it is? Non-uniform cross section. B. No. B is the answer. Let's move further. Okay, done. B. So B is the answer. Not temperature dependent. Now, resistivity in terms of relaxation time is, since I told you m resistivity equals to m over ne square over ne square m over ne square tau. The tau is the relaxation time, n is the electron density, number of electrons per unit volume. So let it be mass of the conductor is constant. So resistivity is inversely proportional to the relaxation time and resistivity is inversely proportional to the electron density. For metals, the electron density remains constant. So if we raise the temperature, the relaxation time decreases because the vibration of the electrons, the successive time of the collision decreases and the resistivity increases and resistivity, so the resistance also increases. So just remember, if we increase the temperature, then the resistivity and the resistance of the conductor increases. This is the formula. RT equals to R naught 1 plus alpha T minus T naught. RT is the temperature at any temperature T. R naught is the R naught is the resistance. Sorry, RT is the resistance of the conductor at temperature T degree centigrade, and R naught is the temperature resistance of the conductor at T at temperature equals to T naught. Alpha is the temperature coefficient. So R naught is the resistance of the conductor at T naught. RT is the resistance of the conductor at T degree centigrade. Alpha is the temperature coefficient. SI unit is per degree centigrade. Similarly, resistivity also. So R rho T equals to resistivity of the conductor at temperature T. Rho naught is the temperature. Rho naught is the resistivity of the conductor at temperature T naught. Alpha is the temperature coefficient. Now this is the formula also. Alpha equals to RT minus R naught over R naught bracket T minus T naught, or alpha equals to again RT minus R naught over R naught T minus T naught. This formula you have to remember. Okay. Now just remember one thing. Alpha is positive for metals, because if we raise the temperature, the resistivity or the resistance increases. So RT is greater than R naught. Hence, alpha will come out to be positive. So alpha is positive for metals. Is it clear till here? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay, Farhad. This is the graph. Fine. For metals, if we increase the temperature, the resistivity increases. So directly proportional.
Sir, can you scroll up? Thank you, sir.
For semiconductor, what happens if we increase the temperature? The resistivity decreases as the electron density increases. Electron density means the number of electrons, the number of charge carrier increases per unit volume. But semiconductor is independent of the relaxation time, and it completely depends on the. If we increase the temperature, the electron density increases exponentially. Hence, the resistivity decreases. So this is the graph. For alloys, if we increase the temperature, the resistivity increases. But in case of metals, if the temperature is 0, the resistance is 0. But if we increase the temperature, the resistance also increases. So the resistivity. But in case of alloys, at temperature at T equals to 0, it has some resistivity, some residual resistivity. Now, 1 minute to do this question fast. Very easy question. Write your answer in chat box. All these questions have already come in NEET exam. So I hope the questions are very easy. 1 minute, write your answer in chat box. Let me tell you one thing. For metals, means for conductors, it would be some like this. Just a minute. Not exactly directly proportional. It's look like this. Fine. So this is the metal. This is the graph for metal or conductor. This is copper. This is copper. This is the answer. Fine. D is for alloys, not for copper. All right. Because at temperature equals to 0, it has some resistivity. But in case of conductors, the temperature is 0. The resistivity is also 0, or the resistance is 0. All right. So B is the correct answer. Is it okay with everyone?
Yes, sir.
It's not exactly directly proportional, but if we increase the temperature, the resistivity also increases. Now try this question. 3 minutes and write your answer in chat box. Fast. Write your answer in chat box. Fast. Now how to do? If the resistance of the conductor is 5 ohm at 50 degree and 7 ohm at 100 degree, then the mean temperature of the coefficient. So look how to do. Since the formula was RT equals to R naught, 1 plus alpha T minus T naught. Fine. What is that? It be at temperature T. And this T naught basically, if the resistance of the conductor is this, the mean temperature coefficient alpha we have to calculate. The temperature A. Correct. Alan is correct. What is RT? Alan, what is RT?
So RT is 5 over here.
Correct. RT is 5. R naught as it is. At temperature 0 degree, we believe. 1 plus alpha T minus, what is T?
So 100 minus 50. So it'll be,
100 minus 50.
no, I mean it's just 15.
50 minus 0, we can write. You can use this formula this way also. Look, at temperature 0 degree. Okay. You can write as 0 degree. So R0 basically at second equation will be 7 equals to R0, 1 plus alpha 100 minus 0. Fine. So if you solve it, you will get 50. If you solve, this is 5, this is R0, 1 plus 50 alpha. This is 7 equals to R0, 1 plus 100 alpha. This is first equation, this is second equation. Now second divided by first. Is it clear? Till here, everyone. Farhat, Maimuna, Saifullah, is it clear till
Yes,
here?
sir.
Now divide. 7 over 5, R0 will cancel out. 1 plus 100 alpha over 1 plus 50 alpha. Please solve. This is 7 plus 350 alpha equals to 5 plus 500 alpha. So 2 over 2, this is 150 alpha. So alpha will come out 2 over 50. Am I doing wrong? Sorry, right? If you
Yes,
divide
sir.
it, you will get
Yes, 0.01.
0.01 centigrade. So R0 is the resistance at 0 degree. Okay, clear? Shall I move? Maimuna, Farhat, is it clear with everyone?
Yes, sir.
Okay,
Yes,
now
sir.
okay. Saifullah, what is the formula to calculate the alpha? Alpha equals to RT. Just could you please let me know the formula to calculate the temperature coefficient?
Yes. RT minus R0 by R0 times T minus T naught.
What is RT?
Resistance at time T.
Temperature T. What is R0? Alan, what is R0?
So temperature at 0 degree Celsius.
Okay.
This isn't at 0 degree.
Yeah, 0 degree. Now combination of resistances. If the 3 resistors are connected in series, and if we have to calculate the resistance of the combination, so R equivalent equals to R1 plus R2 plus R3. In series, current is same, but potential difference is different. This is potential difference. For n resistors, likewise R1 plus R2, so on. Parallel combination. If let it be 3 resistors are connected in parallel, so R equivalent equals to R1, 1 over R1 plus 1 over R2 dot Rn. I is different, V is same. Now, okay, Farhat, what is the formula to calculate the resistance? What is the formula for drift velocity, Farhat? Farhat,
Yes, sir.
what is the
E
formula?
electron into electric field into the relaxation time by M.
Maimuna, what is the formula to calculate the temperature coefficient alpha? Formula? I think Saifullah told me. Leave it. Maimuna, Hiba, what is the relation between current and drift velocity? Eva, what is the relation between current, drift velocity and current? Try this question fast. 2 to 3 minutes, hardly. Sorry. Fast.
Sir, in the first line, it should be resistivity, right? 12 is resistivity, right?
Yeah, resistivity. But
But it is resistance.
means
First
in
line.
other words, you can say 1 meter resistance equals to 12 ohm. So first of all, we have to calculate the total length of the circular wire. Try 2 minutes and write your answer in chat box. Write your answer in chat box fast. First of all, we have to calculate the total resistance. So 1 meter, 1 meter wire having 12 ohm resistors. First of all, you have to calculate the total length, that is circumference. 2 pi r. So what is 2 pi into what is r? R is radius 10 centimeter. So pi over 5 total length. So total resistance equals to into 12, that is 12 pi over 5. Now these two wires are connected in parallel. If it is a uniform wire, so let it be two resistors. They are connected in parallel. One of them is half of it, that is 6 over 5. Six pi 5. This is also 6 pi over 5. Now add them in parallel. So R equivalent equals to, what is the answer? Alan A, Saifullah A. Just a minute. R equivalent equals to I think 0.6 pi. Is it correct?
Yes, sir.
Yes, sir. This is the answer. This is the answer. This is the answer. Fine. Farad, did you? Okay, good. Aksha, did you get it? Hiba? Try this question fast and write your answer in chat box. 3 resistances. 2 to 3 minutes fast. T. Correct. Now let's do 3 resistors each of 4 ohm are connected to form a triangle. Four ohm, 4 ohm, 4 ohm. That would be A, B, and C. Now we have to calculate the resistance between any two terminals. So these two will be in series. So net resistance will be 8 ohm. It's connected to the 4 ohm in parallel. Fine. So 1/8, 1/4 are equivalent. So what is 4/8 into 12? 8/3 ohm. This is the answer. Everybody, correct. Done. This is for homework. Take a screenshot fast and move further. Done. Shall I move further, Alan? The answer of this question is 8. Okay. Do at home, and if you get any doubt, we can discuss in the next class. We will discuss, sorry. Just a minute. Just a minute. Okay. Now the next topic is EMF. EMF basically is a isonomer. It is not a force. It is potential difference of a battery. So E equals to work done upon Q. So the work done by the cell in moving a unit positive charge through the whole circuit, including the battery. So if it is a circuit, it's a cell, internal resistance R. So the work done by the cell in moving a unit positive charge through the whole circuit is known as EMF. EMF is work done over charge. SI unit is volt or joule per coulomb. Internal resistance. Internal resistance. Basically it is a resistance of the cell. So it is defined as the resistance offered by the electrolyte of the cell to the flow of the charge through it is known as internal resistance. SI unit is ohm. Now terminal potential difference. Terminal potential difference is defined as in a closed circuit. So potential difference between the terminals of the cell is known as terminal potential difference. SI unit is volt. Now let it be this is a circuit. This is external resistance. This is external resistance. This is a battery or a cell. You can say cell. Sorry, battery. This is battery. R is the internal resistance. E is the EMF. If we calculate the total current in the circuit, so I equals to E over total resistance. E is the EMF, that is the potential, that is the total potential difference. You can say EMF of the cell over total resistance. This is the terminal potential difference. This is terminal potential difference. Terminal potential difference. V equals to E minus IR. I is the current, R is the internal resistance, E is the EMF. Now, if I is 0, that is in open circuit, so terminal potential difference equals to EMF of the battery. In case of closed circuit, so EMF is greater than the terminal potential difference. In case of charging, the terminal potential difference is greater than the EMF of the cell when positive is connected to the positive. For example, if we talk about the, if we take an example of our mobile phone. So when we charge, this is the condition. Discharging when we use it. So V equals to E minus IR. It's the case of discharging. When the cell is short circuited, external resistance is 0. So it also becomes 0. Because V equals to IR. As we know that V equals to IR. So if R becomes 0, V equals to 0. Before this question, try this. 3 minutes and write your answer in chat box. Okay. First of all, what is the formula for terminal potential difference, Alan? Alan, what is the formula?
So for what?
What is the formula to calculate the terminal potential difference? V equals to E minus IR. Okay. Everyone, if you know the formula, you will be able to attempt the questions very easily. Now try this question fast. Try this question. Correct. Saifullah, correct answer. Alan, write your answer. Aksha, Mamuna, Farhat, write your answer, please. Without bothering about wrong or right, please. See. Okay, Alan, just let me know how to approach this question first.
Yes, so we use the formula.
Okay, but before that,
So we
first of all, we will
Since-
calculate the current. What is E? So current will, this is the dominating. So what is the net EMF is 18 minus 12. That is 6. Okay, what is the total current? That is 3. So current will be 2 amperes. All right. Now this is if the current flows through this battery. So discharging 18 minus what is I into 2, that is equals to 14 volt. All right, this is the case of discharging, and the current flows. This battery will get discharged and this battery will get charged. So again the V, because all three connections are in parallel, this voltmeter is connected in parallel. So again, let it be V, this is V dash. So 12 minus, sorry, plus 2 into 1, that is 14 volt. In both the cases, we are getting the same. So answer is 14 volt. Okay. How to calculate the current? This battery is dominating. Fine. Both the batteries, like positive is connected to the positive and negative is connected to the negative. So if we have to calculate the current, then we have to take the net EMF, that is 18 minus 6, 18 minus 12, that is 6, and the total resistance, that is 3. So 6 over 3, that is equals to 2 ampere. Fine. Then we have to calculate. This is the case. In 18 volt battery will get discharged and 12 volt battery will get charged. So first of all, we have to calculate the potential, terminal potential difference across the 18 volt battery, that is 18 minus 2 into 2, that is 14 volt. And in the second case also, we have to calculate the 12 volt battery charge, that is 14 volt. Initially it was 12, later it is 14 volts. So in both the cases, the terminal potential difference is 14 volt and this is parallel. The voltmeter is connected in parallel. So the answer is 14 volt. Is it clear to everyone? Next. Try this question. Five minutes fast. Very easy. The current in the given circuit is 4. The current is given. Current we have to calculate. 4.8 volt battery is given. Resistances are given. Calculate the total resistance. Fast. First of all, we have to calculate the net resistance. So what is current? RC and RB both are in series. So R dash, let it be 6 plus 6 is 12. And R equivalent equals to 3 into 12 over 3 plus 12, that is equals to 3 into 12 over, this is 15, 12 over 5, equivalent resistance. Fine. Now current is V over R. What is V? 4.8 over R. How much? B. 2 ampere. Correct answer. Good, Farhat. 2. 2 is the answer. First of all, we will calculate the equivalent resistance. That's it. Is it okay with everyone?
Yes, sir.
Okay. Now, Alan, what is the formula to calculate the temperature coefficient alpha? Fast. Formula for alpha, Alan, fast. Alpha equals to RT minus R naught over R naught T minus T naught. What is R naught? Saifullah, what is R naught?
Temperature 0°C.
Good. What is the formula? What is the relation between current and its velocity? Farhat, I equals to Farhat. Formula.
E by R plus R.
I equals to NEAVD. Alan, what is current density? Formula.
Sir, E by J.
I by J. I over J is the current density. Okay. Is current density is a scalar quantity or vector quantity? Is current density is a scalar quantity or vector quantity? Fast.
Scalar.
Vector. Having same direction as that of current. Direction. In series, which physical quantity remains same? Potential difference or current? In series combination of resistors, which physical quantity remains same? Current or potential difference? Farhat, which physical quantity? Current. Good. Do you have any doubt till here? Does anyone have doubt?
No, sir.
Okay, in the next class, we will discuss combination of cells, color coding, and Kirchhoff's law. Wheatstone bridge also. Okay. Bye. And try all the questions based on these concepts. All right.